You're listening to a podcast from 702 and Cape Talk.
And
702 and Cape Talk.
The Naked Scientist.
well, Chris Smith is back with us this week, and we have just opened our lines taking your science questions on any subjects. Join us as we strip science down to its bare essentials. I was wondering, by the way, why is it called Naked Scientist? Is he sitting there with his PJs on or whatever? No, but he strips down science to its bare essentials. This is an opportunity to satisfy your curiosity about the world as we live in and find out more about the weird and wonderful laws of nature and the wonders of the human body. My gosh, I have so many questions. Well, this is Chris. Chris, are you on air? Welcome and a good morning to you in Cambridge.
Good morning. Good morning. How are you?
Very well. Chris, good morning. The station is yours. This week's topic is, do we land on Jupiter? When will we have the first people on Jupiter, finding out whether there are green men living there? I'm sure you have the answers.
Well, we won't be landing on Jupiter because it's a gas giant planet and you'd be squished. You wouldn't survive there. But this is a big week for space science because a mission which took off in 2011 and has been travelling for 5 years, and it's actually covered a distance of nearly 2 billion miles across the solar system to get to Jupiter. This is the Juno spacecraft. It's a NASA mission, and this spacecraft earlier this week on Tuesday inserted itself into orbit around Jupiter, having approached at some dizzying 160,000 kilometres an hour. Wow. And as it slowed down, it got into orbit successfully around Jupiter, and there it will remain for the next 20 months, initially at a higher orbit and slowly descending. In October, I think it gets down to a much closer orbit, and the spacecraft will be in an elliptical orbit around Jupiter, with Jupiter turning inside the spacecraft, so that over the mission period, slowly the surface of the entire planet will be scanned and analysed by this spacecraft, which is pretty cool. It's a big solar-powered spacecraft. It's got 3 fins, a bit like the blades of a propeller, and it is spinning. And the reason for making it spin is that all the instruments are on the faces of the satellite, the probe, and so as it spins, each of the instruments in turn gets a chance to look at that patch of the surface of Jupiter. And it's going to tell us an enormous amount, because Jupiter is the biggest object, apart from the Sun, in our solar system. It's absolutely huge, maybe 10 to 12 times bigger than the Earth, just in terms of its physical diameter. And the mass is enormous. I mean, something like 300 times more massive than the Earth. And it's made entirely of hydrogen and other gases. There's some hard stuff in the centre, but we don't really know what's there. It has the most dazzling display of aurorae. These are the northern and southern lights at the poles of the planet, caused by the intense magnetic field. It's got an incredibly powerful magnetic field around the planet. So all these things are amenable now to study, and over the next 20 months that data will come back and we'll find out a lot more about one of the most significant objects in our solar system, because Jupiter will tell us a lot about how the solar system formed. At the moment, we've got guesswork to go on. We'll get some more hard facts once this mission goes through, and it's been a success so far. They've got into successful orbit around the planet.
Well, Chris, this is science fiction, but it sounds like it is around the corner. Well, very exciting. We're taking your calls on the Naked Scientists, 011-8830-702, 02144605667, or the SMS line 31702 and 31567, or the tweets on at German Embassy SA. Chris, before I go to the first call-in, what do you? I'm also a politician. What would you say to the critics who say, you know what, we spend billions of dollars for exploring ways to discover what's happening on the Jupiter, while we have poverty on this Earth, while we have droughts, while we have so many things which we have to solve on this very planet? Is everything which is invested into this space exploration really well invested money? What would be your take as scientists and as world citizen?
There's a number of things to consider, and yes, this is expensive, this kind of game. It cost at least $1 billion to get this probe to Juno. But then you have to ask, what is the value added? for that billion spent, what do we get back? Well, yes, we do stimulate science. We understand more about our place in the universe, and understanding more about our human story and our planetary story is important. It's more important sometimes than some of the things that people prioritise on Earth, but they're still spending money on those nonetheless. So therefore, why shouldn't we spend money exploring the universe? That's the first point. The second point is that in solving these sorts of challenges and getting a spacecraft to fly across the solar system for 5 years to complete nearly a 2 billion mile journey, to manage to navigate through some of the most intense radiation fields that the solar system can throw at us and get that technology to work, that tests and pressurizes the system to the maximum. The learning opportunities are absolutely huge, and it forces scientists and engineers to think dynamically, radically and originally about how to solve very hard problems. That inevitably will have fringe benefits for life back here on Earth. And there are really good examples of investing in things like astronomy. The reason we have Wi-Fi, the reason you can walk into a restaurant, a cafe, you can wander around at home and you can browse the internet on mobile devices, swap pictures with people, get help if you need it, find out about your health. The reason we have that technology is because of radio astronomy. The internet is being revolutionized by having to handle big data, much of it originating from huge projects like the space projects that we've been discussing and projects in CERN, Geneva, where the Large Hadron Collider is trying to understand the fabric of the material we're all made of. In order to handle those huge amounts of data, you've got to invent new technologies, which inevitably then improves life for everyone on Earth. And people have often said, in India, half the population of India don't even have access to a toilet. But India is spending money sending probes to Mars and putting satellites into space. Why are they doing that? Well, the answer is you've got to be in it to win it. And in order to extract value from those future technologies, you've got to be there participating. So I think this is a very worthwhile investment.
Well, I see your point, but I think the question is justified. That's why it's good to have an answer from an expert like you. When I came in, they told me, well, the naked scientist, he knows everything. And I thought, my gosh, I would love to be to meet such a person. Now we have a lot of callers who I guess were waiting for the whole week for that moment. Now let's test him, or maybe let's find out what is the real question. So I would have asked, well, why don't you write books? But you do write books, of course. Now let me go to the first call in. It's Andrew from Pretoria. Let me see what's his question. Wants to ask what happened to clusters of collapsed galaxies disks. My gosh, I don't even, well, you answer this, and I'm learning.
Hello.
Yes, Andrew.
Hello,
this
Chris.
is
good morning.
This is 702.
All right.
Here you got Chris.
Hello.
Hi, Andrew. Shoot, we're
Chris.
listening. Go
All right.
ahead.
I spoke to you a couple of weeks ago, but I've got another one for you today. Please bear
lucky
with
me.
It's about the Big Bang Theory. In 2015, the Big Bang Theory was in tatters when astronomers from University of Central Lancashire in England discovered the biggest known structure in the known universe. This was a group of quasars, which is the brightest object in the universe. To cross it at the speed of light, you have to travel for 4 billion years. It was estimated to be the 1/5 of our universe. Since there is no beginning and no end to space and time, our universe can be a trillionth or a quadrillion, nonillion. I think it goes up to 17 if it ever stops. Now, my question is, how something small as an atom can create so much matter? Or there must have been billions of other Big Bangs. Big Bang was suggested by a priest from Belgium in 1927. Teachers and professors are still selling it in schools and universities, and students are still buying it. Your opinion about the Big Bang, please, Chris. Thank you. I listen on the radio.
All right, well, thank you for the provocative thought. Our understanding is that the universe does have a beginning and it does have an age, and that age is roughly, thanks to, it's been refined recently thanks to some missions from the European Space Agency, and this is the Planck mission and the Herschel mission. We understand that the universe is about 13.8 billion years old. That's the time when the Big Bang occurred. At that time, the universe, if you assume that the universe is everything, there was no universe, so everything popped into existence with the Big Bang 13.8 billion years ago. This was a very powerful explosion and the release of an enormous amount of energy, and because E equals mc squared, energy equals mass times the speed of light squared, that was Einstein's equation, then mass and energy can be considered to be interchangeable. We don't exactly know how, but energy can therefore make mass. So via some mechanism, that energy is converted into matter, and there are billions and billions and billions of atoms in the universe. The universe went through a phase of very rapid growth. It inflated very fast, then it slowed down a bit, and in more recent years, its growth is accelerating again. So we live in a universe which is a growing place, and as far as we know, the rules of physics apply everywhere across the universe. It's got both matter, the stuff you can see, that makes up maybe 5% of the mass of the universe. It's also got dark matter, which is this gravitationally active, weakly interacting stuff that we know it's there, but we can't actually measure it yet. And then that's 20%, and then about 75% of the mass of the universe, we don't know what it is, but we do know the universe is growing, and we can infer that this stuff must be there making the universe grow and giving it a push, and we're calling that dark energy, but we don't know what it is. So there's a lot to play for in the worlds of cosmology and astrophysics, I would say.
Chris, I'm flabbergasted. I'm impressed. You know everything. That's true what they say. Back with more of your questions right after this.
702 and Cape Talk.
The Naked Scientist.
We are back at The Naked Scientist. Chris Smith is answering your questions. Now we have a lot of questions on the cosmic issues, but we want to also touch on some other issues. Now here I got a question by Mark from Centurion saying,
Guten Morgen, Herr Botschafter. Ich bin ursprünglich aus Düsseldorf, deswegen sage ich mal ganz schnell Hallo auf Deutsch. Hoffe, dass es Ihnen dafür gefällt. Hi, Chris. I just said hello to the ambassador in German. I've got one that's always perplexed me. You know, you always say that, sort of the time during the day is going to be spent sleeping to basically recuperate and recharge your batteries for the following day. But you might have had this also in the past. You know, you sit through a really boring presentation, you kind of fall asleep, you're nodding off, but you're trying, obviously, not to fall asleep. But invariably, sometimes it does happen. You fall asleep for literally a second or two or three, and that little power nap is already enough to recharge you to last you basically the rest of the day. And I would like to know what actually happens inside your body to make that actually happen like this.
Yes.
I think there's a range of things that go on, Mark. And a very interesting question, by the way, because I think everyone listening to this has experienced the very phenomenon to which you are referring. And there is no struggle as great as the struggle to stay awake when someone is droning on in a really boring way, which is why I try and keep the show interesting. Mm-hmm. But the bottom line is your brain exists cocooned inside a structure called the blood-brain barrier, which isolates the brain chemically from the rest of your body because it's such a delicate neurochemical situation that because of the radical changes in chemistry that happen in your bloodstream, if the brain were being exposed to those changes all the time, then it could potentially disrupt the balance of how the brain is working, and this would obviously upset your thought processes. So the body isolates the brain away from the rest of the bloodstream, but what this does is lead to the accumulation during the waking hours of various waste products and metabolites which are byproducts of brain activity. It's a bit like you dumping stuff into your waste bin, and the waste bin fills up during the day. When you go to bed at night, under carefully controlled situations, the brain opens up the blood-brain barrier and a system called the glymphatic system kicks in and the brain volume expands, tissue fluid flushes through the brain and it washes away all this accumulated debris. It's rather like the bin men coming, although not in Joburg when I was there in April, and collecting all of the rubbish, taking it away, and that resets the system. So on the one hand, part of the restorative effect of sleeping is the cleansing of the brain and the washing away of the accumulated debris and the sleep-inducing molecules that build up during waking hours. There's also evidence when people have done individual recordings from brain cells, they find that as we feel sleepy, it's because rather than populations of brain cells all cheering together, firing off nerve activity like a uniform vote, then individual groups of nerve cells start to drop off and they stop responding quite so well. And sometimes when you have a little nap, then you depower the system for a bit and then relaunch it, and you get more of these nerve cells operating in concert as populations again, and that we know also helps with concentration and makes people feel more alert. So I would say that the power nap you're describing probably is influencing both of those processes.
Well, Chris, why do I feel sleepy after this? Anyway, let's go back to the cosmic issues. Now, I have a challenge for you, Chris. There's one question by Bogosi Kelvin. You've got 1 minute to answer this because it's a question which would take maybe a month. But Kelvin, please come up with your question, and Chris has 1 minute to answer it.
Oh, okay. So I'm being limited in time. Here we go. The phenomena of the black hole. Has anybody, scientists, thought of what goes on beyond the black hole? And secondly, the singularity and the wormhole. Can you please explain those two phenomena? I find them quite fascinating. Thanks.
1 minute, Chris.
Right, well, first of all, what's a black hole? Well, a black hole is something which is so gravitationally active that not even light can escape. Black holes are usually the product of the death of a massive star, which when the star collapses in on itself at the end of its life, then it forms something which is extremely tight, dense and small. This has a very powerfully deforming effect on space. It bends space to such an extent that when light passes, light is bent into this patch of space and it goes round and round and round and can never come out, which is why it's dark, because not even light can escape from a black hole. Because they're very massive, they also, because of Einstein's theory of general relativity, they will also distort time, because space isn't just made of space. Space is a fabric called space-time, and space and time are tethered together. And therefore, if you have a very massive object, it distorts the fabric of space, so time will change as well. So close to a black hole, you will experience time changing at a different rate to an individual who is more distant from the black hole. Now, a wormhole is something quite different. A wormhole is a concept we have whereby you may be able to cover vast distances in space. Instead of having to take the long way round, there might be a shortcut. It might be possible to warp the fabric of space such that a journey which would be impossibly long in human terms could be made as a shortcut and take much less time by bending one remote part of space round to meet another remote part of space. That's the simplest way to think about it. They're a theoretical entity. No one has evidence that these things exist. When we talk about a singularity is, for instance, the Big Bang, how the universe began. And this is a concept of something which is, in all dimensions, basically a point. And rather than the huge universe we see today.
I know 1 minute would be a challenge. I said 1 minute because I have a short question which goes back to 20, 30 years ago when I was in Panama. And in Panama I was coming from one ocean, which is the Atlantic, to the Pacific Ocean. And still, you have the Panama Channel. And then you have these boats and ships, and they have to be elevated or brought down 12 meters or 40 meters because Pacific Ocean and Atlantic Oceans have a difference of 12 meters in height. Why is that? Why is not all water on this planet on the same level?
Well, there's a number of reasons for this. Anyone who's been to the seaside knows that the tide goes in and the tide comes out. Water isn't static on the Earth's surface. It's continuously moving around the Earth. And this is because the Earth is turning inside the orbit of the Moon. The Moon is large and exerts a big gravitational influence on the Earth. also the sun has an influence too, and this draws water to heap it up in one place on the Earth's surface and then an equivalent heap on the opposite side of the Earth. So there are water distribution differences around the Earth's surface just because of tides, and then there are gravitational differences as well. The Earth has a bulge around its middle at the equator, probably because it's spinning and that's the way that the mass settles best. But also there are things like ice sheets, and Antarctica is both mass because of land and a huge amount of ice. And in this way, it's very gravitationally active and it pulls water down towards the South Pole. So if we lost all the ice from the South Pole, then there would be a very big rise in sea level worldwide, just because of where the water is currently distributed under gravity down towards the South Pole. So it is too simplistic to assume that because water can just find the lowest level in a bucket or in your kitchen sink, it will do the same things in the oceans, because the Earth works slightly differently because it's much bigger and it has all these other things going on.